Alright guys, to begin with, I have this Compactlogic that my company threw into the garbage container because I believe the fuse that goes here blew up several times, and I thought, man, it's got internal damage, the motherboard is damaged. And well, I like to recycle stuff and decided to give it a shot and took it apart and remove a daughter board from the main power supply. This here, it's the first stage of the power supply. It has two polyester type capacitors in series with a 24-volt input, 24-volt DC supply. It's wired here to the terminal block here on the PLC. This is a positive, this is a negative. I got a 24-volt power supply here. So this do filter the DC, and then you have a inductor that will it's like to reject common mode noise. So you got this inductor with a ferrite core to which the 24-volt positive and negative lines run through, and then you got this varistor here that the central tap of the varistors are grounded to the shield or the chassis ground. There, this is chassis ground. And you have this diode, this it's two diodes paired together with a center tap, so the cathodes are connected together. That's a center tap. It looks like a transistor, but it's a dual diode with a center tap, and then you got I believe it's a MOSFET. It's an RF 2807, and I don't know if these two are shorted, so it causes the fuse that goes in here to blow up. So they replaced the fuse several times, and they decided, to just throw it away. It's useless. Well, I removed this and rewired the power supply within. You can see the power supply there. It's got a 35-volt electrolytic capacitor. I think it's like 68,000 microfarads. That is the ferrite core transformer. That is like a DC to DC converter. It's like a flyback type of converter. It generates the 5 volts and then 3 volts or 3.3 volts that are needed for the Broadcom and the Freescale microprocessors are inside the main board here. So it works. As you can see, there is some program running. What I do not know about this PLC is its IP address. I found it's not running the boot protocol, so I cannot initiate the boot protocol with it. I got the both the boot P application from Rockwell, and I got one from Beckhoff, but I don't think the boot P option is set on this PLC. Actually, I removed the battery, the lithium battery. I thought it would revert to the default settings, but I guess the mega capacitor inside kept the charge on for several minutes. I was welding the power supply and it kept that alive. So I fixed the power supply, and then I wanted to find the IP address, and so I have this handy Python program that, sorry about the flash, I don't know if I can disable the flash on it. It's a Python program. It's called Ping All that I wrote. What it basically does, it does is, let me just open Notepad++ here. What this does, it just goes through a range of IP addresses. Like I will think that was the first two octets would be 192.168, and then the last two octets would be in this range, 0 to 255. And with 1 second interval between pinging events, I've calculated it will take 18 hours to scroll between this two range, 0 to 255, and here 0 to 255. So if you range those two, it will take you like 18 hours to go through the whole range of IP addresses. But those are commonly the most used ones in automation. You probably leave those two first octets on. So this is just detective stuff. This is the most common. You leave these two octets on, and then you just set the range on these two. And that was the case. I mean, the script is running right now. I can tell it's running. And it found itself. It found the PC IP address, which is set to 0.100, and it found a device at 1.111. So I believe that's the IP address. So I'm gonna cancel this script here in Python. I'm gonna change the actually no, I don't need to change that. Just gonna go here to Aris links and see if it can see the PLC. See that? Okay. Okay, set backup hour, whatever. I didn't find those, so let me set the IP address. I said running, configure. No, I'm looking at not the Wi-Fi, but the Realtek. Yeah, that's the one I want. Okay. Close. Trying to find the PLC on it. Configure, stop. Configure. PC Realtek. Yeah, that's the one. Okay. Start. Close. And I don't know if I can see it. Because if I ping 192, 168, 168.1.111, that's the PLC. It's pinging the PLC. Okay, let me see why. I probably need to change my network settings here. Properties. This is a PIP. Okay, I'm gonna change myself to the same subnet. Now that I know what the IP address is, I'm just gonna set that way. Sorry about that. Okay, just change the IP settings to the same. I'm gonna close this. That's the Python. And I disable this. Auto refresh. There it is. You can see it. Oh, what is that? It found something. Okay, so let me open up Logix 500. I don't know if I got the right firmware for it. Maybe not. I'm not sure. Maybe I will. I'm just not sure if I have the right version of Logix. I don't know if I need a Studio 5000. Sorry about that. Okay. Who active? Who's active? Okay. Then. Okay, found a PLC and upload. To upload, okay, it's got version 19.11. To upload from this control, you need to resolution support for this firmware. Okay, so probably gonna have to control flash that. That's L3E L23. Let me see, that's the L23 QB1B. And it's same 11769 L23E. This is right. It's the same one. 1769 L23E dash QB1B, right? All right. Okay. Oh yeah, I need to set the PLC into program mode, and it's currently set to run. Okay, remote. Okay. Transmitting. Okay. What's wrong with that? Blah blah blah. Okay. Okay. Next. That's it. Once more. Okay. It's not in the proper mode. So that's what it says. Okay, I set it to programming now. It's no longer remote. This is it. Okay. Next. Finished. Okay, finally it's updating. So it has to be in it says block one of 3, block 1 of 1100/90. So I've actually never flashed the firmware into a Compactlogic, but I'm doing it now because I only got version 20 and this was a version 19 firmware PLC. So in order to work with it, I need to flash the firmware from version 20 into it. But like I said, this was a discarded PLC just because this, either the transistor here, the MOSFET, or the diode are damaged. I have yet to remove them to test them, find out what's wrong with them, and probably resolder this in place. This is just like a filter, actually. This is just like a gating system, like a over voltage sensing device that will probably trip in case the voltage exceeds some level and protect the power, the PLC from over voltage surges. So it's actually useful, but as you can see now, the PLC is running. As long as you keep a good stable power supply, I think it will be okay, because I could probably Google for the components and find the components. So it's pulling for power up. So here you can see the PLC is doing something here. It's like, okay, the HC is doing some shit. About 100 seconds. So it's like waiting for the firmware to become stable. So DHC is now orange. Channel 0 is orange. Okay, still blinking. I mean, updating firmware is not something that is to be taken lightly. I mean, like when you buy an Arduino, it should come with a boot, but it comes with firmware. Basically, it's just like a bootloader on which other programs are run. I mean, because if you're someone like me who has programmed with PICs, you know, when you're programming with PIC, you're actually writing everything into it. Now, where's my PIC? It's gotta be somewhere. Yeah, so I have a Microchip. I think it's an 18. Yeah, I think it's an 18 one. Wait, no, it's a 16. I don't know if you guys can see it. It's a 16 F. Wait, I can try to see the numbers here. It's 16. I can see it. I need my glasses. It's an 877. So this is it's an 8-bit microcontroller, a program using C language, and you just do in-chip, in-circuit serial programming here. And I use PIC2 to program it. You know that there is no firmware on a PIC, so you're just basically creating a program, and that's something that was very common and back in the days of the Zilog or Intel stuff. So PLC is basically a computer. It's got a proprietary firmware, and I mean, your BIOS on a PC, that's a firmware, right? The operating system runs on top of that. So the BIOS is telling you how the system works, like how much RAM it has, and how many hard disk drives there are, how many serial USB ports, parallel ports and stuff. So so still 40 seconds to go. Just gotta wait until that happens, because I mean, updating firmware is critical. When you update your BIOS on a laptop, you gotta be very careful. I mean, you gotta have the right BIOS for your laptop, because if you load the wrong BIOS, you'll end up with a, what you call a brick. You turn your PC into a brick. It won't run, and it's very hard to unflash it, because you need to like go inside and actually mess with the flash chip or the BIOS. Probably replace it with one has the right BIOS. Like up here, I got a router, a Linksys Cisco router. That's my hotspot, and that I install DDWRT firmware on it. It's a Linux-based open source firmware, and I like that model of router. I actually found several ones on Goodwill. I got a whole bunch here of routers, and I installed the DDWRT firmware because it's very customizable, and it's open source, and it's Linux, so you can do telnet to it and stuff. Okay, since it's completed, they complete, and you got the PLC ready to run. It's running. Okay, so that is completed. Okay, cancel. So what to control? Yes. Okay, so this annoying thing. Okay, I'm trying to. Oh, communications. Who active? Upload. It's gonna upload. This is no project. Okay, there's no project. Just what I thought. I mean, it's basically no project in it, because yeah, I was suspecting the IP address in it is 53 somehow. So I don't know exactly what my Python script found. It said it found something on 111. I don't know, maybe that's something else on the PLC, because I can ping to it like I did here. See that? 11. I can ping to it. There's something on that IP address, and I can ping to 53, which is, oops, that's another thing. So I'm not sure exactly. Okay, it's 53. That I have to write down. So let's just create a new project. Okay, that's it. Yeah. Vision. Dumpster PLC. Oops. PLC. Okay, dumpster PL. No, not dumpster. Not dumpster. Dumpster. It was dump, not dumb. Okay. Gonna give it a minute. So it's pretty neat. I have something like that. I mean, how much are these worth? I don't know. Do you think I probably can sell it on eBay? Okay. There it is. Okay. Compact I configuration. Ethernet. Connection. No. Port configuration. IP address. Port diagnostics. Okay. I probably need to work on this. I'm making this video too long for you guys to watch. Okay, but there you have it. I mean, I got a PLC that has, I'm trying to download this. Failed to go online. Control commission, but not needed. Okay. Tools. Path. Okay, I need to probably go here and click here and find. Okay, that's it. PLC. This is it. Download. Oh, I got it wrong. No, I don't. 53 to 23. Is that it? I don't know. Is it? Oh yeah, it's, what do you know? It's Logix 5, I can't read. 323E. That's exactly what Virus Logix found it to be. It's Logix 5323. Why is there a warning on this here? Connection says major fault in controller. Connection timeout. General. Connection status faulted. Why is there no I/O? Compact bus local. Connection timeout. Maybe they damaged the internal bus, so the internal models cannot be found somehow. Maybe I disconnected them by mistake. No, I don't think I have done that. Maybe they're actually damaged. Because no, they should be connected because I'm running power through the back panel, the back plane of the PLC. So the back plane is that ribbon tape connector that runs from the power supply through the output card and the input card, and then finally to the microprocessor here board. So maybe something got screwed up here in the I/O models here. It's not seeing either one, but that's fine. I mean, most of the time they don't use those. I got a PLC that has those. I mean, they're not available, but hey, if I go into run mode, let's see, can I create a logic here? Main routine. Okay, I'm gonna add something here. I'm gonna add, are there no control tags? Okay, I'm gonna add, yeah, it says nothing. It says local. Okay, I'm gonna add text. I'm gonna add internal bits. It's gonna be what? Yeah, double integer. Yeah, that's right. All right. So I got 32 bits. Yeah. Internal bits, 32. All right. Got that. Go to main program, main routine. Just gonna add one contact here and a latching bit, and then I'm gonna make another run here with another here, and another on the unlatching. Alright. And I turn this like internal bits 0.0, and then I'm going to turn this internal bits, let's say 16. Sorry about that, I'm not pointing at the screen. Sorry guys about that. Internal bits 0.1 and unlatching internal bits .16. Okay, I'll just dump that. Yep. It's programming, so it shouldn't do anything drastic. Okay. It says in programming, so I'm gonna run it into run the remote. So, is it running? Yeah. Is it not running? Here it says it's running. Alright. If I, oh, faulted. Yeah, that's why. It says got a fault. This one require connection to establish before I'm going to run mode. Okay. Well, finally it found that its internal discrete inputs are not working somehow. Clear faults. This thing is gonna fault out. I think there's a timeout setting somewhere. Set connection. Yeah, there you are. The I/O controller fault. Well, there is something wrong with this PLC. Let's see if I can disable that. Properties. Can it be disabled? Connection. Inhibit model. Oh yeah, you can inhibit. Major fault uncontrolled if connection fails while in run mode. Apply. Yes. Yeah. Have to be okay. Apply. Yes. And then I'm gonna disable the screed outputs one way. Zero. I think it's the same for both. Okay. Okay, so I'm gonna there and clear the faults. I'm sorry, I'm not pointing the phone at the screen. That is so unpolite. I'm a terrible cameraman. Okay, send run mode. And I think I disabled the I/O here. Oh, I may need to download the changes. Yeah, it's gonna freak out. Yeah. Inhibit model. Yeah. I need to inhibit the compact bus local. Yeah. I guess the whole thing needs to be disabled and then program download. Oh, apparently not. Alright. Just run it. There, I think it's running now. So I had to disable the internal 16-bit input and internal 16-bit output cards are not working. Something is wrong with them. I guess they damaged them and they caused this to get damaged as well, probably. Who knows? Okay, let me just toggle this. See if it can toggle it. Yeah, change states. If I toggle this a little bit, untoggle this, toggle it, yeah. All right, I got it working. PLC, well, not entirely working. The embedded I/O cards are not working, but it's a Ethernet IP, so you can expand it and use probably distributed I/O like I don't know, backoff or something, and download the EDS sheet or file to it and connect it to whatever uses Ethernet IP. So thumbs up if you like the video. Hope you guys come around and look for more random stuff here on my channel. Thank you for watching.